are you, everybody who is watching this video? I'm very happy to have you today. My name is Olenjolai TAYAI single. Simply just call me Olenjolai. I love you so much, and I have a good news for you, and I would like to apologize before you today. My voice is not good, it's not in its own quality, but don't worry, this is according to the intensive work in order to make sure that everything is going well in every institution that we have online, and also in every online school that we have, because we have 4 online schools. I'm a founder of all the 4 online schools, and also we have 2 online institutions, and also I'm a founder of those institutions. So I have a responsibility to work day and night in order to make sure that I meet God's demands for the humanity in all the 4 online schools and 4 institutions. So the only thing is, keep on praying for me, because I'm really facing the resistance from the kingdoms of the darkness, because you know that I'm bringing light to the nation. I'm bringing light to my own nations. I'm bringing light to the nations, the other countries abroad of Tanzania. So you know the kingdoms of darkness always is resisting such kind of the good news and the light. I'm from Tanzania. I'm a Tanzanian, and I'm living in Tanzania. I'm a Tanzanian. I'm a Tanzanian, okay? I'm also a citizen of my own country. I love so much my own country, and that's why that I'm offering this special gift to God through the people of my country, and also I'm offering this special offering through my teaching gift and even all my resources, that just to make sure that this thing's going well. So I would like to take this opportunity to welcome you into our online institutions that called online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Simultaneously, also I would like to take this opportunity to welcome you into our YouTube channels that called online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. So well, what are we doing in these online institutions? That's a very good questions. Well, so the great thing that we are doing in these online institutions is we are training and we are teaching also students, okay? For these departments, we are dealing with engineering and scientific mathematics for undergraduate. The good thing is actually that we are specializing to prepare the contents of learning and training also the undergraduate students in engineering programs and also in scientific programs. So in applied science, in pure science, you know that mathematics is always supporting the science fields and even the engineering fields. When I say engineering fields, I mean that the hardware engineer and even software engineering, because some of the computer programs, for example, computer science, also they are learning some modules or courses of engineering of mathematics, which is applied mathematics that we are dealing with. We are not dealing with pure mathematics. Okay, so the next question is, what I want to tell you that in online Undergraduate Polytechnic Institute of Tanzania, we have vision, we have mission, we have problem statement, we have solutions of the problem, we have methodologies of solving the problem, we have also main objective, we have also specific objectives, because we are solving a real life problems that is in national level, and even also it is in international level, but currently we are focusing the national level. So this is an assignment that God has given us to teach and train some group of students who will be ready to extract knowledge from the classroom instructions which they are learning formally or informal. When I say formally, it means they used to get this knowledge in the physical institutions or colleges or universities. Informally, possibly that you are studying the open university, maybe in some certain field, or you are studying computer science, but you are studying open university, so that is informally. So these programs will help you, and also it has some contents to make sure that you go far and even you do great things more than your professors expected you to do. So that's why I say that we are training and incubating and teaching some group of students who are ready to extract knowledge from where? Knowledge from the fundamental and the core courses in your area of specialization, and combine that knowledge that we extracted with wisdom with the knowledge and wisdom that we extracting from the Word of God written in the Holy Bible in order to solve real life problems. So our main objective and our main objective in online undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM is to see our continuing students and even our graduating students they are solving real life problems, whether small scale real life problem or large scale real life problem. That will be our joy, and that is our main focus and our main objective. We have also so many specific objectives. For example, to help you to love engineering mathematics and and scientific mathematics is the one of our specific objective. Also, it means that to help you to go through all the process and requirement to accomplish your continuous assessment successful is one of our specific objectives. Again, to prepare you in order to answer questions that you are going to encounter in your final exam or any of semester exams is the one of our specific objectives. So it means that helping you to pass for your exams, is not the main objective of online undergraduate Polytechnic Institute of Tanzania. That is good news to me. What I'm telling you actually, it might seem like it's difficult to implement. Yeah, it is true. Myself, I'm a product of what I'm telling you. Okay, I'm a product of extracting knowledge and wisdom from the informal education that I learned myself on the feet of my Lord Jesus Christ. And also I'm a product of a man or of a graduate student who is extracting knowledge and wisdom from the formal instructions that I've learned from the standard 1 to the undergraduate level. And also I'm a product of one of the servants of God that extracting knowledge and wisdom from the word of God. And also I'm a product of combining these two unlike, or we call it unlike church knowledges, and to solve a real life problems. So what real life problems do I solve? One of them is this one. You need somebody to teach you. And hence you know that it's not simple to teach in the national level. You can teach in the institution level. You can teach in the departmental level. You can teach in the programs level. You can teach in the course level. You can teach, so you see, it's not something easy. Because, for example, we have so many departments in online undergraduate Polytechnic Institute of Tanzania, and one of the departments is called Higher Engineering and Scientific Mathematics. We have also another department which is called the Departments of the Kingdoms of Heaven. So here we are extracting the knowledge and wisdoms of mathematics, in engineering and scientific. And then there in that Departments of Kingdoms of Heaven, we are extracting knowledge and wisdom from the Word of God that written in the Holy Bible. And then now we challenge ourselves on how we can combine these two knowledge and solve a particular real life problem from the small scale to extremely large scale real life problem. So it is possible. It may be taking several months to achieve what I'm telling you. It may be taking several years to achieve what I'm telling you. But the issue is that is our testing. Regardless of how many years are we going to spend to achieve what I'm telling you, regardless of how many several months we are going to spend to achieve, but that is our testing. And that's our point of overrejoice. Okay, I believe that you've understood what I've been presenting. In these departments of higher engineering and scientific mathematics, I'm teaching 12 courses or 12 modules, right? I'm teaching 12 courses and 12 modules, which actually, those 12 courses or 12 modules, they cover everything about engineering mathematics and the scientific mathematics for the undergraduate level. That's what I trust. I've been reviewing different curriculum, I've been reviewing different course outlines. So what I'm telling you, if you combine the knowledge I'm going to pour out in all of these 12 modules, believe me that it's going to give you the entire knowledge of engineering mathematics and scientific mathematics that students used to learn worldwide. However, that currently I focus in the nations of the Tanzania. So any engineering institution, any engineering college or engineering university, any scientific college, any scientific institution, any scientific university can benefit through this program. And this is a supplement of what you used to learn in your class. So one of the modules, of course, is called Differential, Equation, and Complex Variables. So this one, the year of study, I forgot year of study. Okay, year of study. It is first semester in many institutions, first semester, and the second year. First semester in second year. But it depends, it varies. Some of the institutions or universities, they learn these modules as the second semester of the first year. So don't worry about the year of study. The issue is just to deal with the content. So the modules is called, of course, called differential question and complexity variable. And then we have some chapters in this subject. First of all, we categorize these modules, of course, into two parts: differential question itself and complex variables. So in this first part, we are dealing with top chapters of differential question. And we are in chapter 3, which is titled as Power Series Solution of Ordinary Differential Equation near to their ordinary point. And this is subtopic 1, which is Existence Theorem. And this is lecture 9, which is titled as Problem Solving of Ordinary Differential Questions by Using Existence Theorem. Again, I want just to tell you that these programs is worth. But God asked me at Olenjolai, offered to me a freewheeling sense-giving offering to, through the Tanzanians, teach these Tanzanians everything about these 12 modules that I told you free of charge. I won't charge you any amount of money. But again, he told me, according to the book of Exodus 25, verse 1 through 8, I want to dwell with your students, with your online students. So then God, I asked, what should I tell them? Then he asked me that invite them to offer me, not me, to offer God your freewheeling sense-givings for what you are receiving free of charge. Okay? Why? Why should you offer? That's a good question. There is a very high running cost for a single video to be processed in my system or in my systems until it reaches you. So there is very high running cost. So you know, we have a vision in online undergraduate Polytechnic Institute of Tanzania to prepare more than 700 teaching videos. Right? So you know, it's actually intensive, it's a great project, and also it's expensive. It can take much time. But remember, the sponsor of this program is my God, who lives forever and ever. He is God of the gods. So the quality and the greatness of my God is greater than the running cost for this program. But he asked me that, Olenjolai, invite your online students to offer me freewheeling sense-givings through the online transactions of the mobile transaction and even the bank transaction. So in case you feel from your heart, freewheelings from your heart, not from your mind, not from your experience, from your heart, you want to offer God. So this program, you're warmly welcome. You may send your freewheeling sense-giving through this telephone number 0759745331, and your freewheeling sense-giving is going to support 100% of the running cost for this program, so that many videos or many lectures of differential questions and complex variables will be in the air in order to help great engineers and scientists of the present and future generations. Right? So now, ladies and gentlemen, allow me to go into the quick review of lecture 8. Why should I do the quick review? I want to link the previous lecture and then today's lecture. In lecture 8, actually, we told you that we have a theorem that we are using to solve differential question, because we told you that we can find the ordinary point, we can find the singular point of the differential question. But again, so now we need to solve these differential questions which have variable coefficient. Okay, variable coefficient. So this existence theorem states that the solution of the n differential question will be y is equal to the sigma notation from n is equal to 0 as the first counting index to infinity. And then here we have what? We have a subscript of n, then we have x to the power n in a simplified way. And this one also can define and even substitute this first counting index. So this is very important theorem that we'll be dealing with. However, that we began is with x minus x naught, but it's x naught is equal to what? To 0. Okay? So that's about what? Existence theorem. Is there any condition for this to be valid? No any conditions actually. It's a good news. But we can just express in this form. But also we say that why this even the way that we expressed our previous solution, for example 23, okay? So this is n is equal to 0 to what? To infinity. Then here we have a n, then x power n, and this is equal to what? This is equal to a. The German solution is what? Let me check. A arbitrary constant, a y1 of x plus what? b y2 of x. And we saw in example what? In example 23. Again, I told you about identity theorem that we need. Okay? Identity theorem. So the identity theorem has two parts. Okay? It has left hand side, n is equal to 0 to infinity. And then we say that we had what? A, n, for instance, x minus x naught power n. This also is equal to sigma notation, n is equal to 0 to infinity. And then we have what? bn x minus x naught, kx minus x naught power n. So if we simplify, we find that an is equal to bn. And this identity theorem, it's one of the theorems help us in power series solutions to obtain what? Recurrence formula, right? The general equations of recurrence formula. And then I told you how you can solve example 23. If you noticed, I deviated from my culture that I didn't leave any homework to you. Why? Because I wanted your homework was to make sure that you go through, you revise that video 3 times, at least 3 times, and you understand how you can solve example 23 yourself on your own. Okay? So that is all about what we've been discussing. Okay? So today, so you can also access lecture 8 in our YouTube channel called Online Undergraduate Polyinstit of Tanzania square bracket OLENJOLAIM. So today, ladies and gentlemen, let me present to you example 24, which is concept, and remind me to leave the homework today for these students to test on themselves. Okay? So we say that find a power series. So the question is, say, find a power series solution. Find the power series solution. Okay, find the power series solution of the following equation. Of the following equation. Okay? About 30. About the print. About the print. About the print x is equal to 0. This is very important because later on I will teach you the next subtopic when we are solving the other differential questions about the print when x is not equal to 0. Other points rather than 0. So we'll be given our differential equation, which is 1 minus x squared. Then this is second derivative. Okay, divide the x. Then this is minus 2x. Okay. Then here we have what? dy dx. Okay. And there's plus 2y. This is equal to 0. Okay. Write that question, please. Let me give you a few minutes. Let me give you a few minutes so that you can call that question and we can go together. We can solve together. So this is interesting. One of the interesting. So that's why I said that this concept. You have to be careful. One of the interesting differential questions that we are going to solve. The example 23, it was simple because there are only 2 terms. For this one, there are 3 terms, and if we expand, we'll find that we have 1, 2, 3, 4 terms. So 4 terms. So we have enlarged now our term. Before it was 2 terms, right? We had only just the first term and second terms. This equation now will give us to deal with sigma notations of the 4 terms. Get prepared. You can also try these questions to solve on your own. You can pause the video and then try to solve this question on your own, on the rough paper. And then you come and you play, you continue watching the video and see the solutions and correct yourself where you've missed about. I want to tell you that I've been teaching for 5 years. I taught these modules physically at the Institute of Technology, and especially this part and the entire modules that I've been teaching you of differential equation, complex variables, and the rest. I taught you more than 3,000 students. Okay, in 5 years. What actually many students they didn't love this part because it is algebraic. It is solving differential equations, but algebraic. We have to follow so many steps. So many students, they didn't want to bother them while they were studying technology and others were studying pure engineering. So that's not a good habit. You have to be committed, and you have to be serious, and you have to be hard worker. All right? So now let us go to business. Solution. We have to follow almost all the steps that we followed, or we followed in solving example 23. The first step. The first step, we can just adjust like this one, that testing if x is equal to 0 is ordinary point, because the question didn't tell you anything about ordinary point, and it also neither didn't tell you about singular point. So to test it, we say that we have to recall the standard ordinary differential equation, and this is p of x y dash double dash plus q of x y single dash plus r of x y is equal to 0. So this one will make the first equation. Then you have to give an equation which is 1 minus what? X squared. So y double dash, okay? Y double dash minus 2x y single dash, then plus 2y is equal to 0. So this is second equation. So if you compare, we get that p of x is equal to what? 1 minus x squared. Q of x, this will be equal to what? Negative twice x. And then r of x, this is equal to what? 2. We are interested with p of x. You have to recall what? The theorem. So the theorem states that if p of x is equal to x naught is equal to 0, okay, is not equal to 0, then x naught is ordinary. It's ordinary what? It's ordinary point. Okay, so you have to go and test it. So we, after comparison, we form p of x is equal to 1 minus x squared, right? So to find p of x is equal to x naught, if you substitute 0 in x, so you get 1 minus 0 squared. So you find that p of x is equal to x naught is equal to 0. This is equal to 1 minus 0, which is 1. But 1 also is not equal to 0. Therefore, we say that x naught is equal to 0 is ordinary point. So if it's ordinary point, we can apply we can apply existence theorem to solve it. That's how. Those are the procedures. These questions are not difficult actually to solve. You have to follow procedures, and you have to learn those procedures sequentially. And I insist you don't spend your time and waste your time on cramming this step. Just understand this and keep in your mind. You have understood so many difficult issues in life rather than this stuff. All right? Again, I want to tell you, the home of understanding higher engineering mathematics and higher engineering and higher scientific mathematics is online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. We'll be pouring ourselves, we'll be trying to use different techniques, different methodologies to make sure that everybody God brings into these online institutions understand more than his or her expectation. So this is the home of understanding, right? Our main concept and our main focus is everybody to understand what we are teaching, especially who are in this level of undergraduate level. Second stage. Tell your neighbor we are in second stage. Okay, second stage. Second stage, we say that recall existence theorem. Recall what? Existence theorem. Okay, existence theorem, we say that this is y in sigma notations, not in algebraic expression, or in series form, in sigma notation. Okay, n is equal to 0 to infinity. Here we have what? an x power to n. Okay, so you say that you have this is the second equation. So suppose that this is an equation, this is the third equation. Then differentiate, let us find what dy, let us differentiate y, this y are the function. So if we differentiate I told you in the example 29, but I want to repeat, just for the moment, write n is equal to 0 to infinity, and then here we have an, and here we have n x e power n minus 1. Alright? Alright? So then, so when so the y dx, which is equivalent to y sigma dash, when we leave this sigma, this function, derivative function, in this form, then we get a challenge. You know what a challenge are we going to get? If we leave this, sigma notation, this function, this first derivative in this form, the first term will be 0, which is not important in mathematics. For what does it mean? If you substitute n is equal to 0, here it will be a0, and then here we have 0 times x e power 0 minus 1, so everything becoming 0. So the first term is going to become 0, which is not important in mathematics. So because 0 terms is not important in ordinary differential equation or in power series solution, so we as mathematicians, we have to think, what should we do? We have to raise the first counting index. We should not count it in terms of this derivative from n is equal to 0 like in this term, because we counted the terms, or we count the terms here from n is equal to 0, right? While here we are not, if we count terms from n is equal to 0, the first term will be 0, which is not important. So we have to raise the first counting index by 1, but we don't lower the summation index. We don't do anything about the summation index. Actually, because we are going to have 0 plus, so simply, it means that if we write this term, means if we substitute 0 here, we are going to have 0 plus, and then we have the sigma notation. Here we have n is equal to 0 or is equal to 1, because here we got this 0 when substituted n is equal to 0, n is equal to 1, so to infinity. This is an, then we say that this is n x e power n minus 1. So 0 plus these terms, it is this term. Wonderful enough. I taught this model for the 5 years. I want to tell you, God has revealed a great secret for me to understand why are we writing this first counting index by 1 while we don't lower the summation index. I thank God for the revelation. He revealed here, I didn't know in advance this technique. Right? So you are luck. So simply we say that the second term, or the first derivative, the first derivative in sigma notation now will be what? Will be dy dx y sigma dash is equal to sigma notation, okay, of n is equal to 1, n is equal to 1 to what? To infinity of what? Of a of n x power n minus 1. So let's say this is equation 4. Alright, then we go to find what is the second derivative. Okay, so for the second derivative, we have to differentiate the first derivative. d dx of dy dx, this will make what? So we have to differentiate this function. So we have sigma notation. Don't say anything about n is equal to 1, about first counting index to infinity. Then differentiate this. If you differentiate this, you have n first of all, a subscript of n, and then here we have these terms which we have to use the power series to differentiate. Here the n minus 1 become the coefficient of this term, and here we have x power n minus 1 minus 1. Alright? So this will make what? Second derivative, right? Which is equal to y double dash is equal to what? Is equal to sigma notation, n is equal to 1 to infinity. Here we have n, a subscript of n, and then we say multiply n minus 1, and then here we have x e power what? Or n minus 2. Well enough. So let us substitute. So I say that the second derivative, this is equal to y double dash. This is equal to what? So with this case, you say that here we have this process, right? So let us substitute, because if you substitute for n is equal to 1, you'll get 0, because 1 minus 1 is 0. So let us substitute n is equal to 0 and find the first term. So you substitute here n is equal to 0, here it will be 0 times what? A subscript of 0, first, no, 1. Let us substitute n is equal to 1, the first counting index here, to get the first term and then having the series for the other terms, the general formula for the other terms. So it means n is equal to 1, you substitute here it is 1, substitute here it is A1, and then substitute there it is what? 1 minus 1, and then you have there it is x what? 1 minus 2, then plus. So the next term now, the next term will be what? Will be this term. We increment n to become n is equal to 2, right? So then this is infinity, okay? And then here we have what? N, okay? Then n minus 1, a subscript of n, x power n minus 2. So 1 minus 1, it is 0. Wonderful. 1 minus 1 is what? It's 0. So let me clean there. I believe you have copied this. When you find that I'm teaching you with a very high speed, so you cannot write and listen. So I advise you, you can pause the video and write the notes. You can listen and then stop the video, write the notes, and then you continue. So now, the second derivative in sigma notation, which is y double dash, this one is equal to what, ladies and gentlemen? Here you have 1 times a1, 1 minus 1 is 0, 0 times a1 is 0, times 1 is 0, times x power negative 1 is 0. So it is 0 plus what? The next term, which we prefer to say that all the next terms, we write them in sigma notation, in short terms of sigma notation. N is equal to what? 2. Because here it was n, here we got this 0 when n is equal to 1. So when here we have n, then n minus 1, then an x power n minus 2. That's why many lectures of mathematics, they just ask you that to raise the first counting index by 1 when you differentiate the equation, the existence equation, and then to raise again the sigma notations when you find the second derivative in sigma notation. So actually what are they saying? They are just summarizing this piece of information. So right now we have dy dx, which is equal to y double dash. This is equal to what? Is equal to sigma notation, n is equal to 2 to what? To infinity. So here we have n minus 1, okay, n minus 1. Then we have what? A subscript of n, x power n minus 2, and this will be equation 5. Ladies and gentlemen, now we have 5 equations in our process of solving, right? You know what are we going to do? So actually that it will be the first step. The third step or fourth step? Third step. So third step now is a substitute equation what? Equation 3, this one, also equation 4, this one, and what? Equation 5. Where? Into equation 2. What is equation 2? The given differential equation. Equation 2, it was 1 minus x squared, okay, dy dx squared, just to remind you, then this is minus what? Twice x dy dx plus what? Plus 2y, yes, plus 2y is equal to 0. So this is all my differential equations which have variable coefficient. This is the function. Okay. So if that's the case, now we are going to substitute. So this, remember, it was we named it as equation 2. Okay. So to substitute it, we have 1 minus x squared. Okay. And then we say that this is what? Sigma notation. N is equal to 2 to infinity. Then this is n minus 1, a subscript of n, x power n minus 2, plus, not plus, this is minus twice x, and then this is sigma notation, and here n is equal to 1 to infinity. So this is n, a subscript of n, x power n minus 1, and then we say that plus what? plus 2. Then we have a sigma notation. Wonderful, 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 wonderful. N is equal to 0 to infinity. Then we have what? A subscript of n, x power n is equal to 0. Okay, so this is a new equation right now. Because this new equation, alright, we say that this is equation what? Equation 6. Don't worry about having so many equations. They do simplify, and they are writing all the steps in order to simplify your revision when you are get prepared to solve a real life problem, or to when you are preparing yourself for the exam. Because these steps tells you that what you have done there, rather than writing just, because you see, just these numbers and letters. So if you are writing and then you forget that what are we doing here, especially for the physical teaching, which is only, it's done once by the professor, by the lecturer, okay, or assistant lecturer. So it's done only once. So if you forgot, it is gone. At least with this digital technology now, you can review that. What did we do in this step? All right. So then we go for the fourth step. Fourth step, ladies and gentlemen, tell your neighbor we are in the fourth step of solving the equation. The first step, we say that, we say expand and then simplify. So let us expand and simplify equation what? Equation 6. What does it mean? We have this factor. Okay, means we have to expand. We have to expand. These first terms contain this. Also, we have this another factor. We have to expand. It means that we have to insert this equation into the sigma notation. Similar, we have to insert them. So to expand, we'll be dealing with first term and second term. We won't do anything with the third term because we have not. Yes, we have to also, and these two we have to insert inside the sigma notation. So you have to touch all the relative terms, because in mathematics, this we got the first term, and this is we got the second term, and this we got the third term. So if that's the case, you say that it depends. Okay, depend. We can just write one lines, or we can take these terms, expand itself, and then this one itself, and then we restore into the equation equation 6. So let us go. So we expand. We take 1 times these sigma notations, or we take the sigma notations with the nth term, and we apply with 1, right? So what are we going to get, ladies and gentlemen? Tell me, please, tell me. Speak loud, speak out. So we get n is equal to 2 to infinity. 1 times this one, so this is n minus 1, n minus 1, this is an, this is x power n, okay, power n minus 2. Then you say what? Minus what? Minus, so this is sigma notation. Sigma notation, n is equal to 2 to infinity. Okay, so you have what? X squared. So this is n minus 1. Okay, a what? an, and then you are voting x power n minus 2. Then we multiply with what? We multiply with x squared. Okay, so this is all about the first term. For the second term also, we have what? Sigma notation. Our first counting index is n is equal to 1 to n. Then we have what? Twice times sorting n, a subscript of n. Then we have what? X power n minus 1. We multiply with x power 1. Multiply with x power 1. Alright. Then we say what? Plus. Plus what? Now we are going the third term of equation 6. Here the first counting index is n is equal to 0 to infinity, and then here we have n. we don't have n, so we have 2 a subscript of n x power n. Then the entire equation is equal to 0. Wonderful, 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 wonderful. Okay, So then we say that we have to expand. We have expanded. Then we are going to simplify. Are you ready for that? And when we simplify, we have to refer laws of exponent that we taught you during your Form 2. The first topic that called the exponent and radical. During your Form 2, we taught you laws of exponents. So when we taught you laws of exponent, to write the exponent as a function, we have a base, we have a power. Right? So first of all, the base and exponent, we call them power. So the power consists of a base and the exponent. But the law states that the one law of multiplication states that if you multiply two exponential functions which have the same base, then we add the exponents. That's the law that we are going to apply here. You see how mathematics is a sequential subject? Interesting? Yeah. Do you love it? Tell me in the comment section, please. Okay. So we say with this case, we say that, okay, so that is good, that is good, that is good. So we say, okay, so with this term, we don't have any kind of simplification, we just rewrite it. So when you write it, we have what? N is equal to 2 to infinity, and then you have n, then n minus 1, n minus 1, then you have an, then you have what? X power n minus 2. Again, we say that this is minus, okay? So this is minus. With this one, we need to simplify, same base. We add the exponent, n minus 2 plus 2 is equal to what? N. So it means that is simply, we say that this is infinite, n is equal to 2, sigma notations to what? To infinite. So we say that we simplify the same base is x, the base is x, we add exponent n minus 2 plus 2, which is equal to n. So then we copy the terms, so it is n minus 1, then you have a subscript of n, okay? And there we have x in power n. Wonderful, wonderful. Okay, so then here we are. Again, here we have the same base of exponent, the same base of this exponential function of the indices. Then we add what? The exponent. So it will be n minus 1 plus 1, which is equal to n. So then we say that this is minus what? Sigma notation. Okay, n is equal to 1. And here we have infinity. So it is twice n, then a subscript of n. This is x power n. Okay, so it's now becoming the third term. With the fourth term, we have nothing to simplify, ladies and gentlemen. The first counting index here, it is n is equal to 0, 20 to infinity. We have 2 an x power n is equal to 0. Wonderful. So now we have four terms. The first term, we have to name them. The second term, you love engineering mathematics, higher engineering mathematics. Third term, you love. Third term, and this is fourth term. Okay, so this is equation what? 7. Equation 7. Then we are done with the fourth step. We go for the fifth step. The fifth step is just like what I taught you in example 23. We have to check to examine the equation 7 and examine what the generic term, which is x power something. Are the generic terms of these four terms the same, especially in the part of the exponent? No. This is x power n minus 2. Here of x power n, x power n, x power n. So the generic terms of three terms is the same. But the generic terms of the fourth term in that sequence, which is the first term, is not the same with other three. So what we have to do as mathematicians, we have to express all the terms in the same generic term. Right? Are you ready? Okay. Okay, the same all generic terms. So let me look the surface. Express all generic terms in x power n. So the fifth step, express all terms in the generic form. in the generic form. Express all terms in the generic form. Let us express all terms of 40 of equation 7 in the same generic term. As I say, in the same generic terms, generic form, which is x power n. So the second term and third term and fourth term are already in the generic form. We don't touch them. The first term is not in these generic terms of x power n. So you have to deal with this first term. Alright? Are you ready? So to simplify life, what we do as mathematicians, we just take these terms and deal with it itself. Right? Alright? So we have the first term, ladies and gentlemen. N is equal to 2 to infinite. Then here we have what? N times n minus 2. Then we have a n. Then we have x power n minus 2. Okay? So in order to express this term in x power n as the generic terms, we have to do what? Remember that this, I took the first term here. Okay? We have to do what? We have to raise the summation index by what? By 2 and lower the counting index by 2. Right? Fine. So you say that you say raise the summation index. I told you what the means of summation index by what? By 2 and what? And lower the counting index. Lower the counting index by 2. By 2. So if we come here, n is equal to what? 2 minus 2. Okay? And here we have infinite. So we have what? Here we say that we have to lower, and here we have to raise. So n plus 2, and here we have n minus 2 minus 2 minus 1. Excuse me, n minus 1. Excuse me, n minus 1. This isn't? Yes, n minus 1. Thank you, God. So n minus 1 plus what? Plus 2. And then we have a subscript of n. We have to raise this by 2. And also we have x power n minus 2. We have to raise it by 2. So when you simplify this expression, so you find that this is n is equal to what? Is equal to 0. Okay? To infinite. Then we have n plus 2 times what? N plus 1. Then a and subscript of n plus 2. This is x power n. So this is our new first term. It is still the first term, but in the new form. First term. Okay, we've expressed in the general form. Today I want to reduce, I know many students, if I follow me 14 steps to solve, many students they are afraid with the numbering of what of the steps. So I want to avoid having so many steps. Okay, I'm trying my level best to avoid that. So let us take these new first terms and substitute it in equation 7. Right? Let us restore here. Because what we have here, first term, this first term, is the same to this first term. Okay? So the first term is n is equal to 0 to infinite. Then you have n plus 1 times n plus 2. You have a n plus 2. Then you have x power n. That's the first term. The second term is sigma notation. The Greek letter n is equal to 2 to infinite. Then here we have n minus 1. n minus 1, a subscript of n, x power n. So you see, same generic term. Then the third term, so remember that this we call the first term, and this we call the second term. Very important to label them this way. So then the next term we say that it is what? Minus, okay? Minus, n is equal to what? N is equal to 2. N is equal to 2 to infinite. Then you have n minus 1. Then a subscript of n, Then you have x power what? N minus 2, right? Then you have minus, okay? So this is n is equal to 2 to infinite, okay? This is n minus 2, n minus 1, n minus 1. This is a subscript, excuse me, a subscript of a, n, this is the same term. Here we are just copying the third term. The third term, yes, the third term. I made a mistake here. Thank God, thank you God. Thank you my father. Thank you my father. Thank you my daddy. Thank you my dad. I made a mistake. The third term is 2n times a subscript of n x power n. This one. Right. Then I wanted also to make a mistake here on copying the first term, and I thank God because God is in charge. 2 times a subscript of n, then you have what? X n is equal to 0. Right? So because I want to write this in form of the equation, let me just bucket the space. So here we have the sigma notation. Here we have n is equal to what? N is equal to 0. And then we have what? 2an x power n. Okay? This is equal to 0. And this makes equation what? 8. Equation 8. But remember that this is the first term. Ladies and gentlemen, the sixth step now, we have to check our counting index of the 4 terms. Here the counting index, the first counting index is n is equal to 0. Here the first counting index is n is equal to 2. Here is n is equal to 2. No. I made also a mistake. The first counting index here, it is n is equal to what? To 1. Okay, n is equal to 1. The first counting index for the first terms, it is n is equal to 0. First counting index for the second terms, it's n is equal to 2. The first counting index for the third terms is n is equal to 1. The first counting index for the fourth terms, n is equal to what? To 0. So in this case now, what do we say as mathematicians, as engineering mathematicians? Well, so we have to express all the first counting terms of all the 4 terms in that equation 8 in the same counting index. It's interesting. That's how I wrote the concept. So the sixth step, we say that you write the counting index in. Okay, by that. So first term, second term. Okay. So the sixth step. Express all the 4 terms in the same counting index. In the same counting index. The same counting index. So if you analyze the kind of the counting index you have, it is n is equal to 0. The other one's n is equal to 2. The other one's n is equal to 1. What should be the reference? Should we change n is equal to 2, n is equal to 0 to n is equal to 2? Or should we change n is equal to 2 to n is equal to 0? And change n is equal to 1 is equal to 0? What should be the common first counting index? Should be 0 or 2 or 1. According to the rule of differential equation, we have to make sure that if you have these situations that we have, this is the lowest first counting index, this is the intermediate counting index, this is the largest counting index that in terms of value, right? So we have to express all the first counting index in the largest counting index. So it means that what we have to do as mathematicians, we have to change this n, the first counting index n is equal to 0 to n is equal to 2. And also we have to express this n is equal to 1 to n is equal to 2. That's our responsibility. So it means that once we find the term which have n is equal, which its first counting index is n is equal to 2, we don't touch that. So let us count. This one, there's a problem. Second term, yeah, it's already, it's desired what first counting index. First 30 terms, no, we have to work on this. Okay, fourth term, we have to work on that. Okay, so to do this, we can do the best way, we have to work with each term. Okay, we have to work with each term. So to work with each term, we say that we can take that terms, the first term for instance. Okay, we have sigma notation, n is equal to 0, infinite. Then here we have what? N plus 1 times n plus 2, and then we have a subscript of n plus 2. Let me check first of all if it is correct term. Yeah, everything is correct. Yeah, everything is correct. N power t, n power x. So you have a problem here. We have to raise this first counting index into n is equal to 2. So you know what we have to do. If we say that raise the first counting index into n is equal to 2 and lower the summation index by 2, then we are going to disturb your first generated term. So to achieve the first count index of our sigma notations to start from what? 2, then we have to expand, or we have to express these sigma notations in terms of short series of the first term, possibly second terms, and then we have the sigma notations with the n term. What does it mean? Substitute n is equal to 0 here in every place where we have n, So it means when substitute n is equal to 0, what are we going to get? So here we are going to have 0 plus 1, and then again next we are going to get 0 plus 2, and then next we are going to get a 0 plus 2, and then we are going to get 20 x power 0. Right. So this is the first term. The next term will start with counting index of n is equal to 1. Okay? So substitute for n is equal to 1 because our destination is not n is equal to 1. Our destination is n is equal to 2. If you substitute n is equal to 1 into this n term, we get what? 1 plus 1. Then we get again here we have 1 plus 2. Then here we have a 1 plus what? Plus 2. And then we have what? X power 1 plus. So now the next term will be what? Will be starting with the first counting index of 2. So n is equal to 2 to infinite, and then we still have our n term which can help us to get the third term, fourth term, etc., etc. So here we have n plus 1, then this is n plus 2, this is a subscript of n plus 2, then x power n. Next we have to simplify. Power series is beautiful. Power series solutions is beautiful. But don't worry, I'm going to teach you so many examples, and at the end of this topic, you'll find yourself, you are competent enough to deal with this stuff. They become just like simple, just like addition and subtraction operation. Okay, so here we say that now our first term now, which was n is equal to 0 to infinite, n plus 1 times n plus 2, a subscript of n plus 2 x power n. This is equal to what? 0 plus 1, it is 1. 0 plus 2, it is 2. 2 times 1, okay, so that is 2. Then 0 plus 2, which is 2. So we say this one, a of 2, a subscript of 2. X power 0, it is 1. So plus. Here we are, 1 plus 1 is 2. So you have 2. Then here we have what? 1 plus 2, it is 3. So 2 times 3. Then we have 1 plus 1 is 3. So it is a subscript of 3. Then x power 1 is x power 1. That's what? The n term now, which starts with the counting index of n is equal to 2 of infinite. This is n plus 1, and then this is n plus 2, and then this is what? A subscript of n plus 2 x power n. Okay, so this one, let us call it equation what? Equation 9. Okay, so we have to do the same process for the third item. Okay, for the third item. But for the third item, we just find one term and then we increment the counting index into 2, then we are done. So now you know the process. So you can go even straight directly. Here, the first counting index is 1, okay, to define it. And then we have what? 2n. 2n, a subscript of n, x bar n. Okay, x bar n. So we say that with this one, we substitute n is equal to 1. Right? This the, yeah, n is equal to 1. We substitute n is equal to 1. So we substitute n is equal to 1. 2 times what? So it will be 2 times 1. And then it will be a subscript of 1. Then you have x power 1 plus the next term now will be when the first counting index. So you see now, we can write the first counting index by using 2 techniques. The first technique, by raising the first counting index and lowering the summation index by the same factor. The second technique, you can write the first counting index by finding the first term and second term, and then the next terms will be the sigma notations with the new, with the second dot, with the third counting index of that sequence if it starts from n is equal to 0, right? But the second method, when you are writing the first counting index, we don't touch the summation index. That is what secret that even myself I didn't know. God has revealed right now when I'm teaching you. Okay, so n is equal to 2. This is 2n, an, x power n, right? So x power n. So in this one, we have equation 10. Okay, so let us give the first term. The first term, it is n is equal to 0. We have to find first 2 terms. Okay, yeah, it is to infinity. Okay, then we have what? We have 2. Excuse me. This is not minus. The last term is plus. It's plus. I made a mistake here in copy. Okay, it's plus. So this is 2 an x power n. So let us substitute for n is equal to 0. We have 2 a 0 x power 0 plus for n is equal to 1. Substitute them. It is 2 a 1 x power 1. Then we have the sigma notation when n is equal to 2 to define it, and then we have what? 2 an x power what? X power n. Okay. Don't worry that you're about to finish solving this question. Okay, so we say that with this term, n is equal to 0 to what? To infinite, and then we say what? Twice an x power n, this is equal to what? This is equal to 2 a naught plus what? 2a1 x plus what? Sigma notation, n is equal to 2 to infinite, and then we have what? 2an x power n. So this will make equation what? Equation 11. Wonderful. So now we managed to express all the first counting index in the same value. So the next step is what? The seventh step. Okay, seventh step. Seventh step, we say that substitute equation what? Substitute equation 9, equation 10, and 8, equation 11 into equation what? 8. So let us go, ladies and gentlemen. Question 9, it is what? 1 times 2, it is 2a, 2 plus what? 2a2 plus 6, a3, a3x plus sigma notation, n is equal to 2 to infinite, n plus 1, n plus 2, then an x power n. An plus 2, yeah, an plus 2, an plus 2, then x power n, plus or minus. If we check our expression here, the next is minus. So minus, did it touch the second term? No, we have to copy the way it is. So the second term was in the same counting index, desired counting index. N is equal to 2 to what? To infinite. And then this is what? N minus 1, a subscript of n, x power what? X power n. Alright? So n times n minus 1, a minus subscript of n, x power n. Then we go for minus. Then we are dealing with what? So we have to substitute what? Equation 10. So equation 10, 2 times 1 is 2, so minus 2, a1, x power 1. And then we have to minus. Minus is what? N is equal to 2 to infinite of what? Of 2n, an, then x power n. X power what? X power n. Am I right? Yeah. Thank God. Then we say that we have again what? Plus. Equation 11 now. Plus 2, a naught, then plus what? Plus 2, a1, x, plus what? Sigma notation of what? Of n is equal to 2 to what? To infinite, and then say of what? 2an x power n. This is equal to what? This is equal to 0. And this will make equation 12. Wonderful. I believe that you enjoy the beauty of, let me cross check, because I did it on the piece of paper. So you have the 2a2, 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 6a3, x, then plus n1, that one, then minus n times n, okay, that is that one, then minus 2a1 x minus sigma notation of what? N is equal to 2n an x power n, and then we say plus 2a naught plus 2a1 x plus sigma notations of 2an. Yeah, everything is true. I thank God. I thank my Father who is in heaven. So the 8th step now. You know the 8th step? We have to collect the like terms, simplify by collecting the similar terms. Let's say constants x and x power n. So let us simplify equation 12 by collecting the similar terms. When you say the similar terms, what does it mean? There we have terms which are expressed in exponential form. That to say, let us collect the terms which have x power 0, the terms which have x power 1, and the terms that have x power n. Collect them together. Okay? Write them together. Enjoy the week of fire engineering mathematics. Okay, so then let us collect these like terms of x power naught, x power 1, x power n. So to collect them, let us start with, so this is x, for example, this is x power 0. X power 0, so this terms is x power 0. Okay, this is x power 1, this is x power n. Right? Here, this is x power 1, this is x power n. Okay, this is x power 0, x power 1, x power n. So let us collect the terms for x power 0 first. X power 0, the first term is 2a2 plus what? The next term is 2a0. And this one we can multiply with x power 0. Because x power 0 is 1. So let us collect the terms of x power 1. We have 6a3. 6a3. The next one is minus 2a1. So this is x power 1. I still have the other one. I haven't finished. So plus what? 2a1. 2a1 x power 1. Okay? Let me write it properly so you can see everything that's going on. So this is plus, open bracket. We say that 60 a3, then minus 2 a1 plus what? Plus 2 a1, 2a1, and then minus 2a1 x power 1. Then we say plus. If we effect that, because we have so many terms right now, if we check the terms which contain the sigma notation, all the sigma notations have the same first counting index and the last counting index. How many sigma notations do we have? 1, 2, 3, 4. So this sigma notation now is common for all the 4 terms of itself. So n is equal to 2 to define it. So we can have the terms here. So here we have n plus 1 times n plus 2, and hence this one we multiply with what? Multiply with an plus 42. But let me use this square bracket. Again, we have what? We have minus n minus 1, then an. Okay, an. Then we have what again? Minus 2n, an, right? An. And hence, all of these entire expressions, h power n, this is equal to what? We apply now identity property. So if you apply identity property here, we are going to have 0 power x is 0, 0 power times what? X power 1, then we have 0 power x, it means times x power n. This is just for understanding, but this is all about 0. If you add them, they are equal to 0. Okay? So, if that's the case now, the next step, ladies and gentlemen, so we go for the what? The 8th step. So this will make sorting equation 13. So the 8th step, say that we call and we apply the identity property or identity theorem. Identity theorem. Okay, then theorem in equation 13. Equation 13. Okay, equation 13. So if that's the case now, we say that you remember that. I think you do remember about identity theorem, but let me remind you. When n is equal to 0 to infinite a of n, then we say what? Here we have x minus x naught power n. This will be equal to the sigma notation of n is equal to 0 to infinite bn x minus x naught. So if you simplify, it means an is equal to bn. So simply, we can compare this term with 0 times x naught on the right hand side. So it will be 2 a what? A 2 plus what? 2 a naught. Okay? And then instead of x power 0 is equal to 0, x power 0. So x power 0 and x power 0 cancel. So simply, we are going to have 2a naught, 2a2 plus 2a2. Make a2 the subject. To make a2 the subject, this is equal to what? A naught. This will make what? Equation 14. Question 14, okay? So this will make equation 14. Then we say that, let us take what? 6a3 negative 2a1 plus 2a1 is equal to 0. So 6a3 x power 1, this is equal to what? This is equal to 0 and x power 1. So 6 times a3 x power 1 plus 2 cancel is equal to 0, right? So then a3 is equal to 0. It's okay? A3 is equal to 0, yeah. So you can say that because we refer this as equation 15. Don't worry about the number of equations. You can have even 100 equations when you are solving power series solutions problems. So let us now deal with this part, which will give us recurrence formula. Okay? So in this part we say that because even here that we have to say this is sigma notation of m is equal to 2 to infinite. So this one will cancel. So it remains n plus 1 times n plus 2, a subscript of n plus 2. Then we say that minus what? n minus 1, okay, a n. Then say that what? Minus what? 2n, a n, 2m, a n. This is equal to what? This is equal to 0. So let us simplify. Don't we have an plus 1? Let me check. Don't we have an plus 1? Don't we have an plus 1? Let me check. Think here also skip the 1 times plus what? 2n let me cross check. This is 2n, an. I left this one, 2an. Thank you, God. So simply I can say here plus what? 2an. 2an. So here we still have 40 plus 2an is equal to 0. So we have n plus 1 times n plus 2, an plus 2. If you simplify, then we say that at this point you say let's say plus what? Negative, if expand here, this is negative n square minus n, okay, minus n, no, plus n, and then we say that minus 2n, this one, plus 2, and then times what? An is equal to 0. So you have n plus 1, n plus 2, an plus 2. Then she said that this is plus what? negative n square. So here we have minus n. So minus n plus what? Plus 2an is equal to what? 0. Let me check these equations because you have to be careful. You have to be careful enough. If you do a single mistake, then you lose everything. So it is n square minus n plus 2n. So it will be n square minus n minus 2. So it's opposite of that. Substitute negative n square plus n minus 2n. If you have the difference is n square plus n minus 2. So it will be negative n square minus n plus 2. Okay, everything is okay there. And then you have to think. How we can factorize that. Negative n square minus n is n minus 1, n plus 2. Okay, fine. So, it's better, okay, so we have this expression right now. We say that, so this is equation 1, but we can keep on simplifying. Let us simplify negative n square minus n plus 2. If we factorize, this is similar to n minus 1 times n plus 2. Is it? It will be n square minus n minus 2. Okay? What will be minus? Because if you expand here, n times n, it is n square, and this minus is this one, and then n plus 2, it is 2n will be minus 2n. Then we say negative 1 times n, it's negative n, times this negative will be positive n. Then negative 1 times 2, it is negative 2, then times negative is plus 2. Right? So it is negative n square minus what? N plus 2. Yeah, it is true. So it means that simply negative n minus n plus 2, this is equal to what? N minus 1, and then n plus what is plus 2. Alright. So now we are about to get into the recurrence equation or recurrence formula. So then we say that we have n expressed in factors, then n plus 2, an plus 2, an plus 2, then here we have n minus 1, then short n minus 2, an is equal to 0. So this one will make your t, so let me write in form of equation. We had there question 15. So n plus 1 times n plus 2, an plus 2, then plus what? N minus 1, n minus 2, an, this is equal to 0, and this will make equation 16. Okay, question 16. So let us make this the, because let us make this the subject. So let us make A. So we say that will be what? The 9th step. 9th step, say that make A, n plus 2, the subject, make it the subject in A minus n of 40 in equation 16 above the subject. So to make that the subject is a n plus 2 is equal to what? It's equal to negative n minus 1. Okay, because we say that this is what? Yes, so this is, yes, here we have negative. So negative. So if it is negative, this is negative. So even here, this is negative. So it's minus here. So if you bring this on this side, it will be positive. N minus 1 times n minus 2, a, n. So we divide with what? We divide with n plus 1 and then n plus 2. Then this is our recurrence formula. So we say recurrence recurrence formula is what? n plus 2 is equal to what? N minus 1, n minus 2, a subscript of n, of what? Over n plus 1 times n plus 2, okay? Then, but under the condition that when n should start with, n should be greater than or equal to what? What the common first counting index? The common first counting index, it is what? It was n is equal to 2. So n should be greater than what? 2. N should be greater than 2. You are not allowed to round this in exam, but in a learning we are allowed to do this just to insist you to focus on this. So this is our recurrence formula for that equation. Ladies and gentlemen, that's what you have to cover about this session. Okay, so that's the recurrence formula of the given equation. You know now the second step now, or the next step, we have to find the first term, second term, third term, fourth term, and then we write the solution. Are you ready for that? Will you persist? Okay. So ladies and gentlemen, I'm about to end this lecture, so you have to be patient. Don't run away because of how the stars are. You are an engineer and you are also a scientist, right? We're expecting to solve complex problems rather than this. So the 10th step now, we say that express the existence formula or existence theorem in series. So to express existence theorem in series, we say that y n is equal to 0 to infinite, a n x power n, this is equal to what? So this is a naught x power 0 plus a 1 x power 1 plus a2 x power 2, then plus a3 x power 3 plus a4 x power 4 plus a5 x power 5 plus dash. Okay? So that's our C notation. So if we refer now about our solutions, we don't know the value of a naught, so we have a naught here. We don't know the value of a1. We know the value of a2. a2 is equal to a naught. We know the value of a3. So to write this series in this form, we have to find only a4 and a5. It's enough for you to write a series to simplify life, because I know that you are so much exhausted. But you can keep on writing the next terms. This is first, second, third, fourth, fifth, sixth. Okay, 6. You can write even to 10 terms. You are not limited. There's no limit. You can go further in case that you have time. So we say that the 11th step, okay, use recurrence formula to find what? To find, because you have this one, to find what? Finds a4, a5, a6, a7 if you want, etc. So what's our recurrence formula? So we start with n is equal to 2. Always we start with this limit, the first counting index of the sigma notation for all the terms. So if here it is n is equal n greater than or equal to 2, you start when n is equal to 2. If this n is greater than or equal to 1, you start when n is equal to 1. If this n is greater than or equal to 0, start when n is equal to 0. That's the concept. Remember that. Bear it in your mind. So when n is equal to 2, and then we have a recurrence formula, A, so 2 plus 2, this is equal to what? Here is equal to n minus, so n is 2 minus 1, then you have 2 minus 2, okay, 2 minus 2, then a what? A 2 of what? Over 2 plus 1, 2 plus 2, and 2 plus 1. First of all, let me check my recurrence formula, if it is right. Wow, I made a mistake. Here it is negative times n minus 1 times n plus 2. Thank you, God. So I made a mistake on copying this. I wrote negative instead of 40 positive. Okay? So even here I made a mistake. This is positive. And here also I made a mistake. This is positive. So this is our recurrence formula right now. Correct it, please. And this one will be plus 2, because I wonder why I was getting 0. You know what I noticed? We are seeing that the indicator is 2 minus 2, it is 0. So this term is going to be 0. And it's impossible. Right? It's impossible. It's not like in Fourier series. So this is plus. So then we say that A4 is equal to what? 2 minus 1, it is 1. 2 plus 2, it is 4. 4 times 1, it is what? 4. Right? 4 of what? 2 plus 2, 4. 2 plus 1 is 3. 4 times 3, it is 12. 12, A2. So 4 over 12, this is what? 130. Okay? A2. But we know A2. A2 from equation what? Equation 14, it is negative A0. So simply say that A4 is equal to negative 1 over 3 A0. Wonderful. Let me check. A4. Yes, we are right. Only we are right. By the grace of God, we are right. Because doing mistakes in these power series solutions is common. It's common. Because we are following so many steps. Okay? So then we say that we have to find the A5. A5 is substitute in the recurrence formula when n is equal to 3. So it will be A5, and then here it will be what? 3 minus 1, and then 3 plus 2, and then here we have what? 3 plus 1, 3 plus 2, A3. So A5, this is equal to what? 3 minus 1 is 2, 3 plus 2 it is 5, so this makes 10. 3 plus 1 is 4, 3, that is 5, 5 times 4 it is 20. And then so what? A3. So A5, this is equal to what? A half A3. But we know the A3. A3 is equal to what? A3 is equal to 0. According to equation what? 15. Equation 15. So A3 was 0. So a half times 0, this is equal to 0. So A5 is equal to what? 0. So if that's the case, then suppose this series to be equation what? Equation what? Suppose it, because I forgot, suppose this equation x. So you got the 12 steps. Right? The 12 steps, you say that substitute values of what? Of A2, A3, A4, and A5 for this case, is equation what? X. Wonderful. We are about to finish. Then this is y is equal to A0, we don't know. So we have A0, x power 0 is 1. A1 we don't know, so we have A1. Then x power 1. Then A2 we know. A2 is equal to what? Negative A0. So A2 it is negative A0 x squared. Then we go for the A3. A3 it is what? It is 0. Then we go for the A4. A4 is equal to what? Negative A0 over 3 x power what? 4. because here it is x power 3. Then we need what a5. A5 it is 0, x power 5 plus dash dash dash. So then now our series is equal to what? A0 plus what? A1 x1 minus what? A0 x square minus what? A0 over 3 x power 4 plus dash dash dash. So now we can write our general formula. We can write our general solution, not general formula. Exact solution now. In many testing questions, it will be asked to end here. And actually, it is almost you are about to finish, because you see that we just finished within a short time. Okay? So therefore, we say that the solution of our given differential equation is this one. Y is equal to what? A0 is common, so you have A0, which is common. Okay? So you have A0. Then we have 1. Then we have what? We have minus x squared. Then we have what again? Minus x power 4 over 3 plus dash dash dash. Okay? Then plus. For the A1, we have only one term. Okay? We have only one term for A1, which is A1x. If we could continue, just have the terms for the A0. So then, this is the solution. So this is the solution for the given ordinary differential equation. This is what you've been looking for more than 90 minutes. That's what you've been looking for. Good. So, homework 9. Okay? And this is also example 24. Okay? And it is concept. It is concept. Don't worry. Don't be afraid. Find the series solution of x squared minus 4 second derivative plus 3 x minus 2 dy dx plus 5y is equal to 0 in powers of x. So try that. Try to solve it and submit your solution in the comment section. Well, so ladies and gentlemen, this is the end of lecture 9, which was problem solving of by using the existence theorem. I thank God who have created me in his own image and likeness, and who have created the ideal environment for me to live in the planet Earth that is called the gardens of the God. Okay, so I thank God also who have built it and they have given me a gift of teaching. I really appreciate his glory and everything that in me, and everything that I've done is just let I and you give all the glory and praises to him who lives forever and ever. It means to our God, to our everlasting God. I don't deserve any glory and praise on what I've done, because God himself is the one who taught me everything that I've taught you. So he's the one who deserves to receive all the glory and all the honor. So I thank you also. I thank God and I thank you who I thank God and I thank you who have taken your time to be with me from the beginnings of this lecture 9. It's been kind of a long lecture, but that's how engineering mathematics used to be, especially if you are dealing with series. So I really appreciate about your participations. Check this video, watch this video several times as well as you can, until this concept that I've been teaching you just remains in your mind like more than how it used to remain in my mind. Again, when we are learning this stuff, you have to think that where am I going to apply to solve a real life problems that are prepared by God himself for you in order to solve and leave the legacy in the planet Earth. So again, I insist you to subscribe, because we are going to add at least a single video in our online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, especially now on our YouTube account. So we are adding at least one video. So the YouTube community will have a responsibility to give all our online students the notifications once we add a new lecture. So I invite you the next lecture, which will be lecture 10. Also, we'll be still solving problems based on the existence theorem. So I know that you won't miss it, and may God bless you abundantly. I always pray for all my online students, but also I ask you to pray for me as your teacher, as your online teacher who is teaching you online without any physical commitments. Again, my class are not complete without questions from my students. So I ask you, please, if you have any questions about what I taught you, ask it in the comment sections. Another thing that I insist you, because I wish these concepts and these contents to spread, and the message to spread and help millions of the students worldwide at any times and anywhere. So please share these contents with your classmates, with your friends, with other engineers, with your teachers. Share with them that, because they'll find it helpful. So welcome inside the lecture 10. We'll meet there. May God bless you and keep you until we meet.